In this session, let me take you another exciting journey of Seaborn. Now, let's take an example where we want to plot X as total bill, Y as step, data is RDF, kind of plot I want is scatter. And now I'm introducing another variable here, which is column smoker. That means I want to filter my X and Y data with the help of third variable. And then I have introduced another variable, that is the fourth variable, which is the time. There's another variable time in our data set. So row equal to time. Now what I'm telling my library to do is, or my function to do is, that you need to filter data in columns as per the smokers, okay, and you need to filter column in rows as per the time. And this is what you will get. So in columns, since you have mentioned smokers, okay, so you can see smoker, the people who are not smokers are represented here. The people who are smokers are represented here. This is first column, this is second column. This is how Seaborn takes it. Row, you would want time, okay? So this first row, second row. So time was dinner and lunch. These were the two time possibilities that was available in our data, is available in our data. So this is for dinner. So time is dinner, but person is not smoker. Time is dinner, but the person is smoker. The similar way, time is lunch, person is not the smoker. Time is lunch, but the person is smoker. That's the power of using on, that you can actually visualize four variables together. And that's where the Seaborn uh, multiplies the power of the matplotlib library. Similarly, if instead of time, you want to introduce the fourth variable as day, day is another column in our data set, like Sunday, Monday, Tuesday, Monday, Friday, Saturday, then you can use row equal to day. And since you have column smoker, so this is uh, how it will show for every particular day. Let's try it in the interface. So this is what I want to do. Here I have described as row equal to time, and this column equal to smoker. So this is third variable, and then the fourth variable is the row parameter. So if I run this, this is what you get. Now since column is smoker, so first column, second column, the people who are smoker have been shown here, the people are not smoker have been shown here. And since you have shown row equal to time, so time has been taken lunch here first. So the time is lunch, people, person is a smoker. The time is lunch, person is not a smoker. Similarly, the second row is for the time is dinner and the person is smoker. The time is dinner and the person is not the smoker. So this is how, you know, how easily you can visualize four variables together. Two variables as x and y axis, and the remaining two variables according to which you want to filter your data, filter your x and y data sets. Okay? It's so easy. It's so easy to perform these ones. Then similarly, if you want to subgroup by days of the week, so instead of row equal to time, you will provide the row equal to day. And if you run this, you will the following command. Yeah, what you get. Sorry, no, not this one. Yeah, this one. So row equal to day. Since you're specifying row as day, okay. So this is first row. This is second row. Okay. This is Thursday. This is Friday. This row represents Saturday, and this row represents Sunday. So we have 4 days. Now since row is day, first row for Thursday, second row for Friday, third row for Saturday, and fourth row for Sunday. Since you have prescribed column equal to smoker, so first column will have smoker yes. That means day is Thursday, person is a smoker. Day is Friday, person is a smoker. Day is Saturday, person is a smoker, and so on. Second column is when the person is not a smoker. So day is Thursday, the person is not a smoker. The day is Friday, the person is not a smoker. The day is Saturday, and the person is not a smoker, and so on. That's the level of powerful visualization you can do with the help of the REL plot function and the Seaborn library. Then next important thing that you need to understand in the Seaborn is the wrapping and the ordering of columns. Now if you see that uh, the interface can take the ordering itself. It has taken Thursday first, Friday first, Saturday, then Sunday. If you wish, you can specify this order as well. So that is what we call as ordering of columns. And since here the number of columns are 2, number of rows are 4, if you want, you can compress this as well. You can wrap the entire data within significant number of columns. So again, we'll make the necessary imports, and then we have the REL plot function. So X is total bill, and Y I want to take the tip. Data is DF. Kind I want to introduce is scatter. Column day I have mentioned in columns, and I want to wrap this data in 2 columns only. Now please see there are 4 datas that we have, 4 days that we have: Thursday, Friday, Saturday, Sunday. If you are mentioning columns, then ideally it will produce 4 columns to you. One column for Thursday, the second for Friday, then for Saturday, then for Sunday. But if you want to reduce the number of columns, you can use the wrapping function, the column QL underscore wrap. So I want to wrap the data in 2 columns only. So that's why it will give me Thursday, then Friday. Then instead of giving Saturday here, it will give me Saturday in the next line, and then the Sunday. So entire data is set up in columns only. Then if you want to mention a specific column order, so you can mention like Thursday first, Friday first, Saturday first, Sunday first, or want to take reverse, you can do that as well. And finally plt.show. Let's take it in the interface. In the interface, this is the first scenario when I have simply mentioned column equal to day, no other parameter is there. In the second column where I have introduced column equal to day and I have wrapped columns numbers to 2, and the third case where I have wrapped columns to 2 and I have specified the column order as well in a reverse form, which is Sunday, Saturday, Friday, and Thursday. Now I have used plt.show thrice here, so it will show me 3 plots together. Yes. Now let's check. Now the first scenario was when I have mentioned only that I want filter by day in a column subplot. So this is what I have get. Yeah. Just a second. Okay. So first column, second column, third column, fourth column. Now since there are 4 days, so I have received 4 columns here. The first column for Thursday, the second column is for Friday, the third for Saturday, and the fourth for Sunday. In the second scenario, I specifically mentioned that I want to wrap up in 2 columns only. So I have received 2 columns only, first column and the second column, the Thursday, Friday, and then Saturday is not here. It is below Thursday, Saturday, and Sunday. So you can say there are only 2 columns, and all the 4 days have been wrapped in the 2 columns only. In the third scenario, I mentioned another possible parameter that I want to place Sunday first. So Sunday has been shown first, then Saturday, then Friday, and then Thursday. So this is the customized order I want to see in my plot, and I can definitely do that with the help of my Seaborn library and the REL plot function. That's see, it's so easy. I really, I'm so happy that you all are in this course and trying to understand and learn what data visualization is all about. Trust me, it's a very easy job. Just need to know the right parameters and the right way of calling them. That's it, nothing else is required. Then we can have some other ifs and buts that we can do with the plot depending upon the level of customization you want to do. Like for example, uh, when you produce a scatter plot, if you see the level of transparency is not there. That means all the dots are in a single color or maybe in multiple colors, but the level of darkness or the transparency is same in every case. Suppose I want to differ this transparency, then I can have the size parameter here. So I will do the same. I will call the same REL plot function. Then X I want to take as total bill, Y I want to take as step, data is DF, and then kind of plot I want is scatter. I'm introducing another thing here, which is size equal to size. Now what happens when you introduce size equal to size is that the bigger values or where the major chunk lies is shown at a larger size, all right, and the smaller values are shown on a lighter node. So this is how it works. Now these are the bigger chunks which you can see in the black. So this is how the size, how the it gives your visualization a better shape. you are in a better position to make visualization. Okay, these are the areas where most of the major value lies, or major variable is changes in variable is happening. Similarly, you can change the point transparency as well by setting alpha between 0 and 1, which we have discussed earlier, and we will be discussing a lot number of times in bouquet as well. So if you mention the hue equal to size, because as per the size you want to produce alpha, and alpha is zero point 0.4, anything between 1, then this is what you get. So kind scatter, size equal to size, hue equal to size, these two parameters exactly same what I have used here, except that I have introduced one more parameter, which is a parameter, and then finally the plt.show. Now how this works in the interface, that we'll discuss in the next session. Till that time, happy plotting.